Hello and welcome back to another episode of Matrickz Tech Talk. Today we have Leslie Nutteboom all the way from London, and I'm super excited to introduce you, Leslie. Welcome to Matrickz Tech Talk.
Thanks for having me, Hassan.
A little bit about Leslie. He's an award-winning entrepreneur, not one, more than one, and I'm going to name a few. He got the award from Forbes Europe 30 Under 30, MIT Tech European Innovator Award, Under 35 Innovator Award. He was the world champion in solar car racing. Leslie, I'm super impressed. Why don't you tell our audience a little bit about yourself, your passion, and your background?
First of all, thank you for having me, Hassan. I'm really excited actually to have learned about your podcast, and I've learned a lot listening to your talks prior to this call that we're having. But basically, to give you a bit of background about myself, my name is Leslie. I'm one of the co-founders for Humanizing Autonomy. My passion with this type of technology started really early on, actually when I was 15, where I thought, hey, all this technology around us, it's influencing a lot how people behave and how people even react socially with each other. So from that point on, I thought I wanted to be an industrial design engineer because I saw the impact that phones had on people. And I thought, hey, why don't we create something that encourages social interaction in a better way than separating people from each other through screens? And from that point on, I really started kind of growing towards where I am now. And that happened through a bachelor's in industrial design engineering. Then, as you mentioned, building a solar-powered racing car, racing it from Darwin to Adelaide, all the way through Australia, the fastest, so becoming the world champion. To starting my master's at Imperial College London and the Royal College of Art in a course called Innovation Design Engineering. And that course is really about building a prototype for a new technology and seeing how it does in the world and iterating really, really quickly, which actually brought along many, many innovative products into the world. And I'm hoping that we're going to be one of the successful ones of those as well. But so together with Maya and Ronek, my two co-founders, we came up with a product that basically predicts human behavior for automated systems. So what it does is it uses the cameras on vehicles, on cars, on delivery robots, even cameras in the streets to predict what people are going to do so that all these systems can interact with them in a much more natural way. And that kind of brings us back to the beginning, right? Where it's like really technology should be built around people. People shouldn't have to change their behavior to adapt to the technology. It's a technology that needs to understand people and allow us to be our natural selves rather than the other way around.
Fascinating. So you mentioned some stimulating points. So I'm going to start with humanizing autonomy and the example that you gave that the camera of a vehicle should understand people's behavior. So that is a big challenge in automotive industry. I assume that you focus on a broader sectors of industry, but today, for the sake of it, let's focus on automotive industry. This is a challenge in automotive industry that we're facing because whenever a human is driving, the human is perfectly capable of sort of making a good prediction what's going to happen with the pedestrian. If it is a child, what is the child going to do? And that sort of a thing. And when it comes to an autonomous vehicle, it's nearly impossible to teach the software the human behavior prediction. And it sounds like you're about to tell me that it is possible with your technology. Is it even possible, forget about AI, for us to be predictive? Are we predictive? Is our behavior predictive?
Yes, for sure. And you do it all the time as well. When you're driving through a city, you're also predicting all the time what people are doing, whether someone is distracted, whether they want to cross the street or not, and many more predictions. And actually, a computer can be faster than a human because it can focus much more in the relevant areas. It can use many more sensors. It can have a much faster response to things that happen in the environment. So actually, we respond about 2 seconds faster than a human driver to the behavior of a pedestrian. So that's one of the benefits that it brings. It allows you to basically adapt the behavior of the vehicle earlier or warn the human driver earlier. And I think that there's actually a range of development based on the level of autonomy or automated driving. In ADAS systems, for example, you can prevent the accident because basically you can warn the driver or the vehicle earlier than the human driver would. In autonomous vehicles, you can actually enable it to drive faster than they currently are. At the moment, they have to be really cautious because they can't properly predict what the people around it are doing. So to be conservative and to prevent accidents, you have to drive more slowly. But this technology can also prevent false positives. So basically, you can reduce the amount of false alerts that a system would give to a vehicle if you don't fully understand human behavior and if you're only looking at the distances to people, which most of the ADAS systems are doing currently.
That is true. What we are trying to do is imagine a forward collision avoidance system. We are simply, or in a dumb way, calculating. It's not even prediction. It's a calculation of whether I'm going to hit the target or not. And your predictive mechanism will allow me to say, hey, even if it looks like I'm going to hit, but due to certain action from that object, it is not going to be hit. So when we're predicting weather, this is a prediction model. It is difficult but simpler than many other events in real life because our prediction does not influence the outcome. When it comes to stock market prediction, our prediction will influence the outcome. So it's like 2 degrees of complexity in chaos theory. Where does human behavior fall? Which category? Or if there is even a third category that I'm not aware of?
Because of the behavior of the vehicle changes when you understand what the people around the vehicle are doing, you're also changing the behavior of the people around that vehicle because people change their behavior based on what the vehicle is doing. So this must be a continuous learning system that understands how people change their behavior when the vehicle changes its behavior based on what the people are doing. So it's kind of a continuous loop of learning all the time. And I think what's really exciting about this software is that we basically combine behavioral psychology with statistical AI and novel deep learning methods. And those are combined in a modular fashion. So basically you have multiple models that look at different types of human behavior, like is someone distracted? Where in the road are they? Where are they looking at? Do they have an intention to cross? Are they about to jump onto the road? And all those models combined allow you to create a prediction of whether there is a hazard or whether the vehicle is allowed to continue driving like regularly. And what's important about this modular fashion is that not like what you mentioned in your earlier podcast, that if you create these end-to-end systems that are basically trained only on data and learning only from data, rather than being able to decide which of the data or which of the behaviors to really focus on, perhaps through expert knowledge or statistical analysis, you won't be able to understand how well that system is performing. If you create a modular system, like I mentioned, with multiple models looking at different types of behavior and combining that in a more generative way, then you can also output an uncertainty metric. And that uncertainty metric is crucial for the safety of these kinds of systems. Because with uncertainty metrics, you can decide whether you want to trust the camera, whether you want to trust the LiDAR, whether you want to trust any other type of sensor to determine how to respond to a person. And it also allows you to detect edge cases, because that means that if your model is constantly giving a very high uncertainty for certain situations that it starts encountering, such as when people change their behavior to how the vehicle is moving, then you can flag it in the system and you can say, hey, all these behaviors, I don't really know what to do with them. So maybe we need to develop a new model or develop a new behavioral model for what these people are doing so that you can then update the system and make sure that it understands the future.
Fascinating. So you mentioned 3 criteria you modeled, and you talked about the human behavior model. Can you talk about the other 2 a little bit?
So you mean the statistical AI and the deep learning methods?
Yes. So you have 3. You have human behavior model, statistical AI, and deep learning. So tell me how you synergize them. What brings what in the game?
It's also kind of the composition of our team. So basically, we have a behavioral psychologist who actually obtained a PhD in pedestrian behavior specifically.
Interesting. What's the name of one of your co-founders?
No, so he was our second employee. I think maybe third, second or third employee. So this is Dr. Noy. He basically he builds a behavioral model of what pedestrians are doing and measures that statistically through data science. So basically, we've got a massive proprietary data set of scenes that are happening in the street, from dash cams, from ADAS systems, from roadside cameras, and we can validate behavioral models through statistics. Then we develop a neural network that is able to detect such behaviors from camera footage. So basically then using similar data, then you can develop a model that detects that automatically from new camera footage. And then, as I mentioned, through those modular systems, we're able to generate those predictions that then tell you, okay, we can see this behavior happening again. It's likely that the person is going to be in the path of the vehicle in 2 seconds, 3 seconds, with this level of uncertainty. So you can decide whether you want to rely or not on this prediction so that you know how to tell the vehicle to behave or how to warn the driver.
Fascinating. So when you say you're building a neural network to train the system, and you have data that you're testing again, validating again. So what's the source of your data, first of all? Because in machine learning, there's this thing called blame the data. So where's the data coming from, and how do you gather such massive amount of data, and what amount is enough for you to have confidence in your system?
So actually, that's why the whole modular system is very exciting. But the source of the data is from research partners, from our commercial partners, from our government partners. And basically, they give access to many new data that is basically updated on a daily basis. So that means that you can also start detecting new behaviors. That's why, for example, the whole e-scooters were really exciting, because suddenly you had people who were flying by, even though their legs weren't moving. So this was like floating people until you recognized that, hey, they were on an e-scooter. And that's why they were able to move at such high speeds without moving a single part of their body. And those are the types of data that you really need access to if you want to be able to adapt to new things that are happening in the urban environment and new behaviors of people. So that's all fun. But to be able to build a model only on that raw data is really difficult, because you need massive amounts. And that's exactly why you build it in a modular fashion. So if you have separate models that understand the movement of someone's body, the location of someone in 3D space, then you can start not only detecting automatically when these behaviors are occurring, but also you can develop new models much faster because you need much less data. So that's another benefit of building it in a modular way, so a white box solution rather than an end-to-end training only on raw data, because it allows you to tune models really quickly and develop new models based on the existing models that you have. So you need far less data.
Yeah, I like the white box approach in machine learning, because it gives you, it's not straightforward. It's not a classification problem. Prediction is not a classification problem. Having said that, let's talk a little bit about safety. Yeah, when you're driving an autonomous vehicle, let's take an example of a Tesla. Yeah, it does a fantastic job of taking you from point A to point B. However, you're still responsible as a driver, because we're not there yet, not legally, not technologically. It's doing a fantastic job. The problem is when you're driving a Tesla and you're relying, it's behaving so good, it's giving you, until it doesn't. It works most of the time until it doesn't. But when it's working most of the time, there is a chance that you will rely too much on it and you'll probably fall asleep and do something else. Our behavior is changing because the system is safe. So safety is influencing our behavior, and it's kind of like paradoxical. The fact that I'm responsible for it, we know that incidences took place. The fact that I'm responsible for it, I'm becoming more irresponsible because I'm beginning to trust the safety of the technology. How do you think this should be tackled? Or do you even have a solution for this?
I think there's two crucial aspects to technology like that. So the first is education, where you need to educate the people who are using the technology about not only its functionality, but also its limits. And that's also where the technology becomes important, because the technology itself should know its limits. And at that point, warn a driver. I mean, there's always going to be this delay between when the system says, hey, I don't know how to deal with this, and when the driver can take over the steering wheel, for example. But I think that's a crucial step in making these systems more reliable. So first of all, the driver should know its limits, the technology should know its limits, and then I think it's really a design problem. It's an interaction design problem that needs to be solved, because if you want to be able to have the driver respond more safely, then you need to understand how you should inform that driver of that situation, what the most effective way is to get them focused immediately, maybe what the most effective way is to prevent someone from falling asleep while they're trusting too much on this autonomous system. And maybe even the vehicle should understand in what environment it is and where to allow for this system to be enabled and where not to allow for this system to be enabled. Maybe you want to update that basically on the spot based on knowing what is happening in a certain area thanks to roadside cameras, so that the roadside cameras can inform the vehicle system to say, hey, there's something odd happening here. Maybe you want to warn your driver ahead of time so that they know 2 minutes before they arrive at for example, a busy school area, that there are suddenly many children crossing the street, so that the vehicle system knows this is going to be a tough situation for me. I need to warn my human driver ahead of time so that that person has enough time to prepare for what's going to come next, so that you basically create this all-encompassing system. And that's kind of what we're trying to achieve. And that's why I'm saying it's about people interacting with machines and automated systems, not just people interacting with cars. Because you need to make the entire urban environment smarter through roadside cameras, through vehicle cameras, through micro-mobility cameras. Basically anything that interacts with people needs to understand what they're doing, how they can be safe around them, and how to provide the best possible experience for a citizen of an urban environment.
What about the limitations? In what situation do you think your system may fail? And what to do from a safety perspective when your system fails?
That can depend on many things. So like I mentioned, the uncertainty metric will tell us when there are tough situations for the technology. That's something that basically gives you certain edge cases that allows you, even in only the training of the software, to understand what situations it's struggling with, so that you can start adding more data or adding a better understanding of such situations for the technology. Then there are environmental challenges. So it's like, what if it's raining dogs and it's dark? That's going to be a really tough situation for a camera-based solution. So that means maybe you want to basically not allow that system to be enabled if it's a human-driven car, or you want to rely on different sensors that can deal better with such an environment. Then there are sensors that are being blocked. Imagine there's a leaf that blows in front of the camera and sticks to it. Suddenly the car can't see anymore. And that's a situation in which you need to, I would say, stop the car and inform either the driver to clean the sensor, or inform the whole fleet management system that there's an issue with a certain sensor on the car. That's a whole functional safety challenge that I think needs to be addressed before you can fully rely on these types of technologies. And actually, it's quite a challenge for us to understand where we need to sit in that environment. When should we send a warning? We are able to understand that a camera is certainly not seeing anything anymore, but is that really our responsibility, or is it the sensor supplier's responsibility? Or is it the OEM's responsibility who's controlling the entire system? I think that's a massive conversation that we're luckily very involved in through work groups, talking to the British Standards Institute, the Centre for Automated and Connected Vehicles in the UK. We're also getting involved with several research institutes in Germany. So there's many conversations, and I think it will be a massive challenge to understand where the responsibilities lie within which part of the supply chain.
So you mentioned that you're involved with many standardization bodies. Have you looked at SOTIF, Safety of Intended Functionality?
Yeah.
So how does your technology relate to SOTIF? I think this would be something my audience would be really interested in. Yeah.
I think that's actually a really, really challenging question that we haven't solved. And what's really exciting is last month we signed our first production license. So that basically means that there will be many vehicles that are going to be driving around with our technology. And this has really forced us to be aware of these standards, of these kind of methodologies to follow, to understand what our responsibility is, how our software should function, and how it should integrate in a full stack. Now, when the company was started, it was much more of a computer vision kind of technology that wasn't built specifically for automotive. We were using camera data to predict human behavior. We were able to get the camera data from vehicles, but we weren't that aware of all these standards that you need to fulfill and all these requirements that these software need to have before you can actually have them in a working vehicle. So luckily, we've just hired several experienced people from the automotive industry to help me solve this challenge. I'm still reading up on all of them, but basically, like the first steps that we're making towards becoming a certifiable and standardized technology is ISO 9001. I mean, it's basically just the software that you need to make more reliable through those management standards. Second is automotive SPICE, the V cycle, and ISO 26262. So those are the standards that we're trying to fulfill at the moment to be able to have our software into actual vehicles that are being sold and driving on the road. But we're really at the forefront of that process. So actually, I would also love your input on how we should tackle this, because it's really a massive challenge for a technology that's so new and that really no one has ever had to deal with.
Leslie, I want to build on that because this is fascinating. You're a startup. When was your company founded?
3 years ago.
3 years ago. So you're a pretty young startup and you have a fantastic technology, and all of a sudden you realize that, hey, I have to comply with this standard. And you're not the only one in the industry. We have tons of Silicon Valley startups, tons of European startups. We have tons of Israeli startups who are really good at their technology, and they think, and they're right about, assuming that automotive is going to be their playground, without being aware of the traditional hurdles or the requirements, the legal requirements for automotive. So without mentioning, obviously, your trade secrets and the contractual obligation not to mention whatever, is it a part of an ADAS system, or how does it work in the series production? And is it really making decision in terms of safety, your system already?
Yeah, so no, it doesn't. We just provide perception information. We just provide information about the agents, the road users around the vehicle, and we provide that information to the central decision-making system on the vehicle. And that's also the position that we want to have, because we are essentially the best people in understanding what people are going to do around the vehicle. And we want to provide that information, but if you want to decide how the vehicle needs to respond to it, you need far more information. You need to know about the telematics of the vehicle. You need to know whether there's a vehicle behind you. So if you're going to perform an emergency brake for someone crossing the street, then you need to know whether the vehicle behind you is going to continue driving and basically push you forward anyway. So that will decide whether you want to swerve, or maybe whether you want to flag the person behind the vehicle behind you that you are about to brake before you actually perform the emergency brake. So there are many more decisions that you need to make before you can decide whether you want to respond to a road user that we are predicting is about to be in your path. So that's why it is so complex, really, because you need information from maybe even the traction of the tires. You need information about whether the person is capable of taking over the steering wheel or not. You need information about the vehicles around that vehicle. You need to know about the rules of the road, whether you're on a highway, whether you're on a city road, the speed limits. You need to know many more things than only our software output to be able to respond to it safely. And that's why it's difficult to make a decision and decide who is also responsible for making which part of the decision.
Totally. So your territory is in the perception module. So obviously there will be more inputs from different sensors, and there will be a sensor fusion taking place before the body domain controller, BDC, decides what to do. Now, the perception module is important because this is my input for my decision making. And your perception is not merely, if I understood your technology right, not merely, hey, this is an object and categories of the object, or relative velocity of the object and the standards once we do. In ADAS, you're going one step beyond that. You are also sending some predictive data. I think this is what's going to happen in the next 2 seconds, 5 seconds, 10 seconds time frame. Is that how you do it? And you're doing it with certain confidence value. All right. Based on that confidence value and the sensor fusion, the body domain controller of the car is going to make the decision. That sounds great. I'm going to move a little bit toward you as a person. We talked about the technology in a great detail. I love it. What motivated you to go for this startup?
It really matches the value that I have, or the principles that I have with how technology should be developed for people. And basically, when we were graduating, we got a lot of attention with the graduation project that we had. And that graduation project put us in touch with most of the OEMs in the industry, and it gave us a lot of insight in what the challenges really were for the automotive industry. And from that point on, we got awarded several prizes by the European Commission. We got invited to San Francisco to take part in an accelerator, and many more really exciting conversations that really kind of revealed the problem to the three of us. And to us, it wasn't a technological problem, but it was an ideological problem. And it was that basically cars were never really built for the people who are living in the environments that the cars are driving through. They were built for the drivers of the car. So most of the safety features were for protecting the occupants of the vehicle. Most of the interactions that the vehicle provides were for the occupants of the car. But it has a huge impact on the environment and the people who are living in the environment that the cars drive through. So we were like, hey, this seems like a bit of a skewed situation. And it's only going to get exaggerated when you get autonomous vehicles, because suddenly it's not people making decisions about how they're moving through an environment, but it's the software that makes that decision. And who's developing that software? Is that a diverse group of people that have an understanding of different cultures in different cities? Do they actually care about disabled people that are moving through cities? And we felt that there was really a massive gap in industry about how vehicles should interact with people in urban environments. So we said this is a problem that needs to be solved. It's a huge market. There is a massive need from automotive companies, because they confirmed that to us through those talks. And it's a really exciting problem that can grow beyond just the automotive industry. It can basically be any technology that has a camera or that has to interact with a human that could understand human behavior to provide a much more natural interaction, so that you can be yourself. And you don't need to change your behavior. You don't need to be more careful when you cross the street because an autonomous car doesn't understand you. You don't need to adapt the gestures that you have in your culture to make sure that the autonomous car understands what you want to tell it. You can be yourself, and the car will understand you in any environment.
Gotcha. So allow me to kind of like bring out sort of controversial topic. If you have read Malcolm Gladwell's Blink, the book, where he talks about predictive behavior, human behavior. And because we have this predictive behavior model in our brain, whenever something that is a little bit outside of our model, we tend to raise a flag. And that has caused a lot of false positive among human decision. I mean, this entire book is about false positives. Right? So it's like less than 5 seconds is really the decision-making time we have in our brain. When your system will have this predictive model that we probably would resemble the human predictive model, and when something is outside of this pattern does not necessarily mean that we raise a flag. This is what Malcolm Gladwell is trying to say in this book. How do you think that would be tackled in your technology, or will that be a problem?
It's definitely a challenge. And you talked about edge cases in one of your previous podcasts as well. And I think that was actually a really exciting topic, because that really proves the point of requiring the modular approach that we mentioned. And I'm beginning to sound a bit repetitive about the modularity, but basically, if you know where a person is, where they're looking at, and the movement of their body, then you can already start kind of dissecting edge cases in understanding maybe underlying behaviors that are more relevant than the specific edge case. So, for example, if you are driving on the street and suddenly there's a person who's juggling on a motorcycle in the middle of your path, then that's going to be a situation that is likely never to have been in your training data set. But if you at least understand that it's a person, if you understand that they're on something that resembles a bicycle, and if you are seeing that their movements are a bit erratic, then that's already some sort of finding that you can make about what that person is doing, whether they're going to stay in that position or not, and how you want to react to it, even though the system doesn't really understand that that is a person juggling on a motorcycle. So that's why you shouldn't only rely on this end-to-end training system, because that wouldn't understand what this is, what that weird object is. But if you can at least split it up in those components, you'll have a better understanding of what's really happening in front of you. And that's one of the big problems, I feel, that currently exists with ODDs that are being set in standardization work groups. And that's actually something that we're really proud of having contributed to the connected automated vehicle standards in the UK, where we really fought for vulnerable road users to have their own definition in the operational design domain. In most of these conversations, they're just being defined as dynamic agents. And I would say that people are far more important than just being described as a dynamic agent without even understanding any of the components of what it means to be a human and how a vehicle needs to react to it. So that's, in my opinion, essential that you build an understanding of the diversity of human behavior, the unexpectedness of human behavior, and at least determine what are the core things that vehicles need to understand about people when they're driving through a city.
I couldn't agree with you more, because, maybe in today's environment, if you call human being or any vehicle a dynamic object, a dynamic agent, it may hold today. But if you look at the way the technology is moving, we'll be having unmanned delivery vehicles. We'll have unmanned aerial vehicles. That would change the whole dynamics of the way we look at the whole technology, and this will bring another type of dimension in your field, because now you're not only dealing with human behavior prediction, you're dealing with predicting the unmanned object or unmanned anything that dynamic agent, if you will, and that would be an interesting mix. AI, predictive AI or predictive AI of, predictive AI. So you have to move one way forward. Moving back to your entrepreneurship question that I was going to get to. We both get too excited with technology, but I do have some questions that would be very relevant for my audience. Is, how was the beginning? Because some of the questions that I get from my audience that, they're willing to be an entrepreneur, they're willing to make their first move, but it's just that they wait for the right time, they wait for the right environment, they don't have the inertia, they don't have the move. How did that happen? You mentioned that you got a lot of support from your project that got a lot of popularity and stuff. But I'm sure you faced hurdles as well. You faced difficulties as well. And talk about the difficulties.
I tend to always focus on the positive side. But I think one of the core difficulties is who to listen to. Actually, the first difficulty, which I think we tackled pretty well, is to not stay in your basement and develop a product that you think is relevant, but after you get out of your basement after a year, you realize that really you've solved the wrong problem, or you've solved the problem that doesn't exist. So I think that's the first thing that I would tell anyone is just get out there as quickly as possible, get as much feedback about what you're planning on developing, preferably through a prototype that people believe is real, so that basically you get honest feedback about what it is that you're trying to sell them. And then second is to decide who you want to listen to, because everyone is going to have a very different opinion about what it is that you built, but you need to select whose opinion is relevant, whose opinion is going to bring you further. And that's the most difficult thing, because sometimes you've got really experienced people in the field who've been working there for 30 years and working at the big companies that you're trying to sell to, but they're thinking in an old-fashioned way. So that will steer you towards something that is maybe relevant at the moment, but in 5 years, it's just going to be useless. So I think that's one of our biggest challenges, which is, okay, which industry leaders are we believing, are we deciding to follow, and do we stay in touch with to make sure that what we're developing is going to be relevant in 5 years, but also provides a near-term benefit. And that's going to be my third point, which is we started out as an autonomous vehicle technology. And 3 years ago, that was a massive hype. Everyone believed that we were going to have autonomous vehicles in 2020. Well, there are some, but it's not as widespread as the promises that were there 3 years ago. So actually, within the first year, we realized we cannot go further only developing an autonomous technology that uses the most powerful GPUs, that is integrated in the smartest software stack that exists. We need to provide a technology that can make current day cars safer. And all of that has culminated, and it took 2.5 years from that point, to signing a production license for human-driven vehicles last month. And that was kind of, for me, a relief. Like, there was 2 years of stress and extremely hard work without a proper confirmation of this is a technology that can be used right now until last month. And then suddenly kind of the skies cleared and we were like, it's real, it exists, people want this kind of technology and they're going to sign a license for it. And I think that's really crucial to make sure that not only you have a proper long-term vision of something that's going to be huge and really relevant in the future, but also helps people out now. Because if you can't prove that, then you really can't prove that it's also going to be relevant in the future.
You said that you got a license signed. That is fantastic. How about people who did not want to buy your licenses? I'm sure you went to many. And out of how many no's was this yes coming from?
We definitely signed many pre-production licenses. So those we would see as kind of experiments. People want to try out the software, want to see how relevant it is to them, whether it's something that solves a problem for them now, or whether it's going to solve a problem for them in the future. Some people sign those deals only for marketing purposes. So basically they just want to show that they're working with innovative startups, that they have an innovative technology, but really it's not going to go anywhere. And that's something that you really want to find out early on. So you want to understand, what is the road to production? Who do I need to impress to be able to bring this to the next step after we've gone through this marketing exercise? And oftentimes you'll find that there isn't a real plan. And that's when it starts to become really important for you to decide, is this really an organization that I want to be working with? Because it's going to take up resources, it's going to take up time, but you're not sure that it's going to go ahead after this pre-production license. So I think that's really important to also realize. Basically, who's there to put a fancy stamp on it, or who's there to make this a real thing?
What was the enabler for this series production license? Was it your ASPICE? Was it ISO 26262 certification? Was it SOTIF? What was it?
Actually, those standards only came about later in the negotiations. One way in which we had been proving the benefit of our technology is basically how much earlier than a human driver can we react to a certain situation. And you can prove that without any of those standards. You basically only need camera footage from vehicles, the reaction of the driver to a certain situation, and then the output of our software. And then you can start calculating false positives, false negatives, time difference between the flag that we put and when the driver starts braking. And that's a very compelling argument to say, yes, we would be able to warn this person earlier than how they had reacted in the real world. And then after you've convinced people of that, you need to give them comfort that that's real. So basically, you need to perform studies, you need to write white papers, you need to prove that it works in other companies or other organizations on other data sets. So there's a lot of proving before someone is really willing to trust that this is something that's going to work. And from that point on, once there was trust, it was like, okay, but now this needs to be in a proper automotive system. So that means you need to have these ISO standards, you need to follow these development practices. And then we're like, okay, let's do that together, because you've got much more experience. You've been working in the automotive industry for many, many years. You know exactly how to bring a technology like ours into a proper ADAS stack. So we're using the expertise of the tier one supplier to also make sure that we become compliant with all the requirements of the automotive industry, so that it's not only relying on ourselves.
Fascinating. Leslie, one last question to you. We're going to face massive disruption in the automotive industry. Disruptions like AV is going to change the society. Electrification is going to change the society, the environment, hopefully positively. And connected vehicle is also going to change the way we commute, with the way we work, the way we live. What do you think would be the most positive and the most negative aspect of these disruptions and revolution, evolution, whatever you want to call in the automotive industry?
The last podcast of yours that I listened to was, what is the biggest impact on humanity that the changes in automotive are bringing? And I was so dissatisfied with the answer, because I felt like, come on, there's so many opportunities and there's so much exciting stuff happening in the world that is basically going to have a massive impact on how people are experiencing not only driving the vehicles, but also being driven, the vehicles driving around them. So basically the most positive impact that I believe that all these technological developments are going to have is going to be more equitable. Basically, what that means is it's not only going to be the comfort of the really fancy car drivers that is being optimized for, but it's the comfort of everyone in the entire environment. It's about creating mobility solutions for people who couldn't previously afford vehicles. It's about providing mobility to people who are living in areas that were previously very difficult to reach. It's about making vehicles safer. There are so many people dying each year just because of negligence of human drivers. As you mentioned, I think it was 35% that you said that was based on alcohol and drug use. I mean, these are all things of the past, right? At least I want to make sure that these become things of the past. Mm. And I'm sure that there are many people with me who are trying to achieve that change. It's going to be more equal. It's going to be safer. It's going to be more pleasant. All of those things, I would say, are very positive changes for the world in the next 5, 10, 20 years. I think they'll come very quickly. If you think about the negative side of things, one real challenge I see is sustainability. So if all this technology becomes so much cheaper, so much more efficient, so much more affordable, is it going to go the positive way, which I see as you need fewer vehicles serving more people because they are more efficient and because they can perform more tasks? Or is the reduction in price going to cause that suddenly everyone is ordering everything every day? So is it going to clog our cities? Is it going to require many more resources than we need today to provide the same level of mobility? So I think that's something to always keep in mind, which is, yes, you're creating a safer, you're creating a more pleasant, you're creating a more efficient environment, but the right policies need to be in place and the right human behaviors need to be in place to make sure that it doesn't become a depletive system rather than contributing system.
Love it. Thank you that you did not mention that what will happen to the human drivers, because this is a point a lot of people bring up, but I'm kind of like I'm convinced that we went through a lot of revolutions, industrial revolutions, and people were talking about the same thing. What happens is human life gets better. They end up doing something better. We always can give extreme examples, But also when it comes to, we all know for a fact that autonomous vehicle is making us safer. But again, the focus is on that 1, 2, 3 incidents that was taking place. And in the other podcast the other day, I was giving this example. In 2017, there was a plane crash in Germany. And there were like 200 to 300 people lost their life, which is very sad. There are 3,500 people dying every year in Germany in automotive accidents. They're never in the newspaper. We got so numb about the fact that we'll be losing life in our street. We really care about 200 people, which we should, but we don't have enough focus on 3,500. And similarly, I think we're focusing on AI-caused accidents way too much because the whole media is looking at it, but we're kind of forgetting that we're actually in pure numbers saving lives. So I totally agree with you, Leslie. It was lovely having you. I think the audience is going to love this episode. If you have comments, questions, please feel free to write in the comment section below. We'd love to hear from you. Thank you so much for being with us. See you in the next episode. Thank you, Leslie.
Thanks, Hassan. Thanks for the really inspiring podcast. It's been really fun speaking to you, and I'm hoping that we're going to speak more often.
Absolutely.